We also took time away from the Turk unit to work on fraction kits, which again is an area model, but instead of using geoboards, it was actually using construction paper. So they didn't have to worry about the number of squares inside a half or the number of squares. It just actually gave them a visual thing. And now that we've gotten back into the Turk unit, their understanding of the geoboard is better, but they're not keeping the whole consistent. Like if they take a hole and they cut it in half and then they cut the half into 4 pieces, they see those as quarters.
Now,
they
you
don't
understand
see those as eighths.
that business of not being able to keep the whole constant is very common.
Absolutely.
And it's one of the
right.
parts that's hard for fourth graders.
Right, which is, and the other thing that I need to move them away from is if I say to them, okay, you have this shape, this geoboard shape, cut it into thirds. How do you know it's a third? They say because a third has 8 pieces out of 24.
8 units.
8 units. And they're not seeing it as, well, if I gave you 36, the third would change. It would still be a third of 36, but they're really relying on the numbers instead of as the concept of a third is 1 out of 3 parts of a whole.
So it makes sense to switch the model.
Right.
And see if you can get at the thirdness of something.
Right.
Okay.
Or at the even the quarterness of something, or the halfness. So this lesson has them sharing 7 brownies among 4 people. And there's a number, I came up with 3 different ways to solve it. And what I liked about the numbers is that it lent it to the idea of, well, you know, I just share out, like one of the solutions, I just share out my 4 holes, and then I have to split into halves and into quarters, and I liked that they were manipulating the fractions in different ways. And this is a kind of an easy start, and if it's too easy for some of them, I want them to work with sharing 4 brownies among 5 people.
It may not be too easy in the sense that it's they're unusual numbers, so you're not going to get exactly a half or a third, for one thing, and it's a completely different model. It's a ratio model. So kids who are generally thinking about area when they're thinking about fraction don't necessarily make the leap right away into a ratio. So I wouldn't be surprised if it wasn't so easy for kids, although maybe it will be for somebody.
Well, I think the labeling of it's going to be a challenge as well. Like if one of the requirements is what fraction or how much does each person get,
part of it is you want the equal size pieces, but the other part is what are you going to call the portion that everybody gets? Especially because a lot of kids are going to split it in half like this. They're going to be able to make these halves, and then they're going to make these fourths, and you're going to see the same issue that you've seen before, and they're not going to know what the whole is. So they're going to call that a fourth, and they're going to call that a half, and what's a fourth and a half? You know, a fourth of what? A half of what? So that'll get you to the same place.
And then when I'm circulating around the room and looking for their work, I want to see evidence of the 3 different ways, or maybe there's more ways, and have predetermine who's going to demonstrate their way of solving the problem or explaining what their thinking is. And I'm thinking 20 minutes is enough for them to do this.
How many of them have thought about a mixed number as a whole and 3/4, and how they could make sense out of something like fractions, whether or not you've taught a particular concept? That's an old idea that we should teach the concept first, and then give the problem that matches the concept. Give the problem and then see what emerges to know where to go next.
So if their share is just, oh, well, I have a totally different way. This is how I figured it out. Are these equal? I mean, I'm thinking my share is going to have to focus on, are these equal? Did you divide it in a way that the fractional pieces are equal? Is each person getting the same amount? And how can it be that, you know, is 7/4 the same amount as that first solution we saw, or the second solution that we saw?
And 1/4.
So if my Congress gets just that part out, that there's 3 different ways and they all mean the same thing, but they look different, I think that's a big piece. That's a big piece.
So I think you seem to have found most of the ways that kids will.
I thought maybe they'll just cut them all.
I think a lot of kids, well, actually they're only dividing by 4. So
well, I think that
most
of them will just
a lot
share
of them
them out.
might do this shared business, and then the half. This is the one I predict will be the one that most kids do.
The whole plus a half
Although
plus a quarter.
some kids will do this. And then thinking about whether these 7 pieces is the same as this and how that could be proved would be the content that you want to get at from the Congress.
See, another way I thought is maybe they'd share out the first 4 and then split all these into little pieces. 4
So
pieces
I like
at
the
a
way
time,
that you're
so.
predicting what they're going to do. That's really important. And then also thinking ahead about what are the crucial questions that you have to ask in order to bring out the content. So what you're trying to bring out is, what is the whole? And in this case, the whole is 7 brownies. And then there are other concepts here. What is the name of the portion? And in this case, you could have several names depending on how you dish it out. And then the third part is, how do you know they're equal? Is there a way of proving that each of these different portions are actually equal?
That's for the discussion afterwards, right?
Do you have a sense of what you're going to ask them to write?
I don't want to have them write their process. Oh, well,
Yeah, I
first
don't
we
think
thought,
so.
no.
I
want
think
them
that's
to,
enough.
I want to be able to look at this picture and figure out how much is each person going to get. I would imagine that some kids will have little people and each section is like laid out nicely. I would imagine that some kids will maybe take away all the rest and just put the portion. Each person is going to get this much and just have that there. It's going to depend on how they choose to solve it.
Okay, so then as we're watching them work, we're going to look to see who to present, first of all, which is the most common solution, and then what order you might ask kids to present. And you might have a second question tucked in the back of your brain in case some of the children finish early and this does appear easy, which I would be surprised, but it might happen with your PEMA or someone like that. So I would just change the numbers. What if there were...
Sharing the 4 brownies among 5 people?
There you go.
They said that gets into 20ths.
Sure. So then I would say, try this. Would you get a bigger portion or a smaller portion? How do you know? That kind of thing. But I wouldn't expect to get to the conversation of the second one at all.
Well, part of me worries that we're not even going to get to a conversation within the given time that we have.
Well,
just because sometimes that takes a little longer. But my intro, I think, is going to be really short.
Yeah, you don't
I'm
need
just going to build the context. I drew the little picture of the 4 people. That, I'm going to say, this is our problem that we're going to try to figure out. Not a whole lot of build-up.
And go for
All
it.
your materials are on your tables. Choose partners from your tables. Get going.
So they're just going to pick a partner from their table. And I think you're right in making it partner work and not group work, because there's only enough work here for 2 people to be thinking about, not 4 people. I'm very curious to see how they respond to a different model and whether anybody jumps to 7/4. You could ask things like, do you think you're going to have more than a whole brownie or less than a whole brownie? And I could have wrote the book.
You could have. How many brownies do you think each person will get? Do you think each person will get about 1 brownie, about 2 brownies, more than 2 brownies? See if you can find out exactly how many brownies or how much brownies each person will get.
Yeah, I think it's worth asking a couple of those questions before you start, definitely.
Okay.
Just watch the time.
And then when they come up, I'm going to pull the board over and have them actually put up their work and talk about it from there. And the kids will sit in double circle format.
And we'll just watch the order to call the kids up in.
I'm not really sure of which order.
Well, it seems to me I might go with this. If someone comes up with this, I might go with this first, because this would call it 7/4. First of all, I would see if a child came up with that idea. In other words, does a child say, well, look, we could add 1/4 and 1/4 and 1/4 and 1/4 and that's 7/4? If not, towards the end of the conversation, you might make a string of 1/4 and say, how would you add these up? What would you call these things? And then see if you could push for that kind of thinking coming from the child rather than to demonstrate it. If you don't get it from the children, then demonstrate it. I wouldn't hedge from not demonstrating, but push first for that. And see if you get it. And then notice, for example, that the 7 is greater than the 4. You might ask a question like, well, what do you notice about this fraction? Does this look like any other fraction you've seen before? What's different about it? What's the same about it? And see if somebody notices that the numerator is greater than the denominator. Would you think it's more than a whole?
Well, in the Congress, should I be focusing on getting the different ways up or going deeply on one way?
I would first start by, I would build my ways. So at first I would want to get all 3 ways up.
See, that's a chunk of time.
Yeah.
If I'm going to have kids repeat back and say, you know, I understand it, or what did she say? Can you put it in your own words? That in and of itself takes about 10 to 12 minutes, 4 minutes a person, 4 minutes a group.
But I think it's worth it.
I think it's definitely worth it. We may just get those 3 up and have the class responsible for understanding that there are 3 different ways and these are the ways they work, and then get into the math on a different day.
Right, and that's okay. You know
That's
this
okay.
conversation's going to go over 2 or 3 days.
Good.
This is not going to happen in one
It's
day.
not going to happen by 10:15.
Sure.
Good. Okay.
And I wouldn't worry about that.
Okay.
Because this is the first in a string of these kind of problems.
Right.
For one thing. And for another thing, what's the point of going really fast? Then nobody got anything out of
Exactly.
it. Right?
Just making sure.
Yep.
Okay.
Sounds good to me.
All right.
Okay.
Thanks.